Okay, students, now I will solve another example for distance and displacement. If we have this shape, the track from A to D passing through B and C, if I go through this track, this will be a distance or a displacement. It will be distance. How much that distance in this case? It will be 5 plus 6 plus 5, which is 16 meters. How much the displacement? It is from A to D this directly, which is the same as this displacement, which is 6 meters. Now if I need to calculate the speed will be calculated by using the distance, not the displacement, because the speed is not a vector quantity, which is this track, which is equal now to 16 meters over the time, which is 8 seconds. In this case it will be 2 meters per second over 1. It's okay. If I need to calculate the velocity, which is the displacement, in this case it is 6 meters over the same time, seconds, which is equal to 0.75 meters per second. Now this is simple because I know the distance and the displacement directly, but what if I have a different problem? Now I need to understand the figure. I need to find the average speed and the average velocity. What is the difference uh, uh, between the average speed and speed in the first example here? It is the same. This one also is speed average, and this is velocity average value. We will see now how to apply and calculate the average speed and the average velocity. If we need to calculate the average speed, it will be a distance divided by a period of time. Also, if I need to compute average velocity, it will be equal to displacement over time. How can I know the distance and the displacement? I need to know the position of a moving body or person or car or something. Now I have many points, A, B, and C, and I have a girl and a boy, a walking girl and a running boy. I need to calculate the speed and the velocity, the average speed and the average velocity for both of them. Who has the speed and who has the velocity? Remember that the average speed is not vector, but the velocity is a vector. Where is the vector in this movement between the girl and the boy? The movement of the girl is a vector quantity, and this value from A to B, this arrow is a displacement. But this track is a distance. So I need to calculate speed here, which is average speed, and also I need to calculate average velocity here from A to B and also from B to C. Let us do it now. Now the average velocity from A to B, which is equal to the displacement between them, which is XA and XB. The displacement between them equal to XB minus XA divided by the period of time, which is time at point B minus the time at point A. I'm starting solving. In this case, T and X at B, they are final values. This is T final and this is X final. Also, T at A is T initial and X at A is X initial. Now, if I start calculating, I need to put the time in minutes. So I need to use it in this case. XB equal to 300 meters minus 0 over the time is 4 minus 0, which is equal to 300 over 4. This value is equal to 75 meters per minute. This is the average velocity. I can also name it V average. If I take it as a vector, it is to the minus x-axis. Okay, now I need to use the seconds, not the minutes, in my units. So this value is equal to, or from the beginning I can change the time in seconds. I will do that. TA is equal to 0 minutes, which is equal to 0 seconds. TB is equal to 4 minutes, which is equal to 4. Each minute is 60 seconds. Just I substitute 60 seconds in minutes. So TB is equal to 240 seconds. TC is equal to 10 minutes, which is equal to 10 minutes. The minute, each minute is 60 seconds. So is equal T at C is equal to 600 seconds. Now the boy and the girl pass the tracks at the given times. The boy and the girl are met here at this point because the boy is faster than her. They met here and then they continue each one in his track. Okay, I will calculate now the average velocity again, but in seconds. V average from A to B is equal to delta X over delta T, which is equal to X final minus X initial over T final minus T initial, which is also equal to XB minus XA over TB minus TA. All this is in meters and this in seconds. In this case, V average from A to B is equal to 300 minus 0 divided by 240 minus 0, which is equal to 1.25 meters per second. It is a vector quantity, so I need to put the direction in minus x direction, or to the left, or to the west. Okay, now I will compute also the average velocity from B to C. The average velocity means that I could calculate the velocity for the girl, not for the boy. Okay, because it is a vector quantity in this case, which is equal to delta x over delta t again, and equal to x c minus x b, which is x final minus x initial, over t final, which is x t c minus t b. In my case here, xc is 800 meters minus xb is 300 meters divided by t at c 10 minutes, which is equal to 600 seconds minus 240 seconds. This is in meters, seconds, seconds. Also, I can put them in this way: 800 minus 300, 600 minus 240. I can put them meters per second on a side. The final value will be equal to, it will be easy, 500 over 360 meters per second, which is equal to 1.389 meters per second. We need to see here the velocity from B to C is 1.38, but the velocity from A to B is 1.25. Here, for the second part, the gear was faster than the first one. So what if I need to calculate the average velocity through all the track from A to C? It will be in this way. Look at this. V average from A to C, which is equal to delta x from A to C over delta t from A to C, which is equal to x final, which is x at C, minus x initial, which is x at A, divided by t final, which is tc, minus ta. I can put the values now, which is equal to x at C 800 minus 0 divided by t at C 10 minutes, which is 600 seconds, minus 0 second at the point A. Now this is equal to 800 over 600, which is equal to 1.3 okay, meters per second. This is the average value. We have three average values. Average value, the average from A to B is equal to, as we compute it now, it is 1.25 meters per second. The average from B to C is equal to 1.389 meters per second, and the V average, the final value from A to C, that is depend on the first point and the final point, which is 1.3 meters per second. Now we calculate the average value of the velocity for the gear, because it is velocity, because it is a vector from A to B to C. Now I need to calculate the speed. The speed is for the boy. The speed I will use in the speed, I will use the distance. I will not use the displacement. Okay. But wait now, I have a different track for this boy. I have half a circle. Okay, what is the length of this track? I know that for a circle which has a radius r, that all of this the distance is equal to 2 pi r, is equal to the total distance s. Okay, but I have a half circle, not a full one, so I need to divide it by 2. For the track from A to B, this is A and this is B. This track, this is its radius r, and this is s, is equal to the distance, which is equal 2 by r, but divided by 2. So the 2 will cancel with the 2, which is equal to by r. Okay, how much r? The radius in this case. The radius is a length. We know that the girl walked from A to B, and the displacement was 300 meters from A to B. From A to B, 300 meters. So half of this distance is 150. This is equal to r. So S is equal to pi multiplied by r, which is 150. Okay, I can use it and can compute it. 150 by is equal to 471 point approximately 24 meters. This is the distance from A to B. Now I have also another distance from B to C. I need to know the radius here, radius B to C. This is the radius from A to B. I know that the displacement from B to C is 800 minus 300, not 800. The 800 is from A to C. So the displacement from B to C is 500 meters. Half of it is equal to 250 meters. So S from B to C is equal to by, not 2 by, because we divided by 2, by multiplied by the radius, which is 250. In this case, S is equal to 700 5.4 meters. Now I have two distances, the distance from A to B and the distance from B to C. Now I can compute the speed. The speed is not a vector because I have no constant direction for this path and this path for the running boy. Okay, I need to calculate the average speed from A to B, which is equal to the distance divided by the time. In this case, the distance is S from A to B divided by the time. The time, it is the same time, which is 4 minutes. We computed, which is 240 seconds. So this will be equal to 471.24 meters divided by 240 seconds, meters per seconds, which is equal to 'the average speed is equal to 1.9635 meters per second. Also, I can write it as speed average. It's okay. Now I need also to compute the average speed from B to C, which is equal to the distance from B to C is SBC over the time. The time from B to C is 10 minutes minus 4 minutes, which is 6 minutes. In this case, if you remember that, we take 600 minus 240 seconds. So the time here is 600 minus 240 minutes in seconds. This will be equal to SBC is 785.4 divided by 360 meters per second, which is equal to 2.18 approximately meters per second. This is the average speed from B to C. We can note that the average speed for the boy is more than the average velocity for the girl because the distance of the running boy is more than the displacement for the gear, and they met at each point, so he should be faster than here. Yes, that's right. He is faster than here because look at here. Her velocity from A to B is 1.25, but his speed is faster here, 1.96. Also, her velocity from B to C is 1.38, and his speed is more than 2. He's faster. Now I'll compute his total speed from A to C. In this case, I will do this. I will use the new paper. He passed through these two tracks, A, B, C, and this distance is 471.24 meters, and this distance is 785.4 meters. So the distance, total distance, is equal to, we need to add them together, 1256.64 meters. This is the total distance. How much the total time? The total time is, as we see, 4 minutes, 10 minutes. From here, from A to C, he spent 10 minutes as the girl spent. Okay, 10 minutes. So the total time is equal to 10 minutes, which is equal to 600 seconds. Now I can compute the average speed, not velocity, from A to C. In this case, I will use the total distance, which is 1256.64 divided by 600 meters per second. Okay, divided by 600. The last total speed, 2.0944 meters per second. We can approximate this, remove these two digits. So now, if we look at the speed and the velocity, the speed average from A to B, it was, how much the value? It is 1.96, and we can approximate this, meters per second. The speed average value from B to C is equal to 2.18 meters per second, and the average speed from A to C in the total path is equal to 2.09 meters per second. We can see now that the speed of the running boy is more than the velocity for the walking girl. In each track from A to B, from B to C, and from A directly to C, you can compute these values. Now, the last page in this sheet is this one. We need to use graph. I will use this simply graph now, and I will use another one later in another sheet. Okay, we need to understand how to use the plane of x, y, the xy plane. You need to do that. In mathematics, we know that x and y plane, and we can draw any function between through them. But in physics, we don't have always x and y. We have time, position, distance, velocity, or something else. Okay, on x-axis we have the time. So this is 0 time at the origin. We have 1 second, 2 seconds, 3 seconds, and so on. And the displacement on the y-axis. So this is the position. This is 1 meter, 2 meter, 3 meters, because we have the unit here and we have the unit here. Okay. What if I ask you, where is the position of the body? This is a moving body. Where's the position at t equal to 0? It is at the origin. If we have, this is the line, this is 1 meter, 2 meters, 3 meters, 4 meters, and so on. We are here at t equals 0. Okay, at t equal 1, where we are at a distance or displacement 1. This is at t equal 1. Okay, at t equal 5, this is at t equal 5, we have moved to x equal, in this case we have here t, and here the position, maybe we can name it x or y or anything else. So at t equal 5, we have position 5. This is 5. This is at t equal 5. At t equal 6, we are at the same position. At t equal 7.5, we are at the same position. At t equal 8, 9, 10, we are at the same position. So we spend the time from 5 to 10, and we are at the same position. That means we are standing and stopping. We don't have any movement here. We are here for 1, 2, 3, 4, 5 seconds. But the first track from time 0 to time 5 seconds, we are moving. We are change our place and position. Okay? Okay, now at t equal 10 seconds, we know that we at x equal 5. Okay, at t equal 11, we are at x equal 3. We come backward to x equal 3. So we go and then come back. At t equal 12, we are at x equal 1. At t equal 12, after 12 seconds. At t equal 12 and a half, approximately, we go back to our first position. I can understand many things from this graph. Okay, if I need to calculate the speed during the time from 0 to 4, 0 to 4. If I need to calculate the speed, I don't know where is my movement. Is it in x direction, y direction? So it is speed. I don't know where is my direction, so I can't call it velocity. Okay, the speed is equal to delta x, or the change in position, over delta t, which is equal to x final minus x initial over t final minus t initial. In our case, it is x at t equal 4, so I will put it x4 minus x0 from 0 to 4 over t4 minus t0. This is equal to x at t equal 4 is 4 meters minus x at t equal 0, it is 0. T4, which is 4 seconds, minus 0, which is equal 4 minus 0, 4. 4 minus 0 is 4, which is 4 over 4. And the value is, the speed is, or the average speed is 1 meters per second. Okay, calculate the speed during the time from 6 to 8. 6 to 8. This is 6 and this is 8. That's easy. Speed from 6 to 8 is equal to x at 8 minus x at 6 over t at 8 minus t at 6, which is equal to x at 8, this is x at 8, is equal to 5, minus x at 6, it's the same value, 5, because we were stopping here. Okay, the time t at 8, 8 minus 6, which is equal to 0 meters per second. If we have velocity and speed or speed 0, that means we are stopping. We are, and you can remember, if you can remember, and you can, the slope, which is equal to delta y over delta x, which is equal to y2 minus y1 over x2 minus x1. In this case, y final minus y initial over x final minus x initial. But in our case, this is position. Position means x. I suppose it x. I can suppose it y. It's okay. x2 minus x1. But the x axis here is time. So I will take it t2 minus t1. Okay, the slope, if it is in mathematics, delta y over delta x, and in physics I see that the slope is delta x over delta t. Delta x over delta t is the definition of the speed and velocity if I know the direction. The speed in this case I can call it average speed. You can compute also the average speed in this period from t equal 10 to t equal 12 or 12 and a half, and you will find that x final is less than x initial, and the value will not be positive. It will be not. It will be negative value. The negative value means that the body or the movement, car or the person, is moving in the opposite direction, not in the positive direction, because we suppose that the right direction is positive and we compute here positive values, and there's no positive and negative for the zero, and the negative value means that the body moves to the left or to the opposite direction. Is that clear? Thank you.